Cloud Developer Certification Session number 2. So we're going to start. Okay, Roman start recording. That's great. Okay, we're going to start. So let's see. This is session 2. Just a reminder, this is session 2. And of course, we have our co-hosting from many of our GDG community. There's a list over here is almost close to 10 of them. So GDG Hudson, Indianapolis, Baltimore, Ocala, Tampa Bay, Capital Region, San Jose, Austin, Cloud Fremont, and Fremont. So I think I know some of the GDG region that I talked to some of you, and thank you for co-hosting with us, and thank you for working with us. Today we're going to also have raffle. So we have raffle 2 items today. So the items is on this slide. So we have I think this is a notebook, a t-shirt, a cup, a hat, and the socks. So we're going to be doing the raffle at the end, close to the end of the session. I think Roman's going to help me out to run the raffle at the end. Yeah, so Roman put the links out, so you can scan. I'll leave this slide up for a minute, so you can actually scan the QR code. You can get the link and then open the form and then fill out the form and submit it when you get a chance. And Roman also posts the link into the chat. So tonight's agendas, we're going to review what we have talked about last session, and then tonight's session basically focusing on developing application with Google Cloud. So we're going to talk about some of the foundation that we have to know, aware about, and how to build an application in Google Cloud. Hopefully we have some time for Q&A. If not, we can take Q&A through Slack, through the chat, and Ruben will be helping me out with that. And then we're going to touch on what's coming next in the next session. So we're going to look at the journey. So here we are. So we've done week 1 2 weeks ago. Tonight we are on week 2. So we're going to be talking about developing application with Google Cloud Foundations. So this is the developing application with Google Cloud session. And tonight's some of the topic that we're going to be covering tonight is basically the data storage option, authorization, authentication, application intelligence, and application deployment, and some of the compute option, how you deploy your application. And then more importantly, we don't have to forget about the application monitoring and performing tuning. And that's very critical to deploying in any application anyway. Especially in Google Cloud, they have all the tools allow you to do all the monitoring yourself. So I'm going to touch a little bit very briefly on the lab that we have done during this course. This is a very simple Python application called Bookshelf. So I'm going to touch on some of the foundations. So before I talk about that, so let's think about when you're building a traditional or legacy applications, right? You're building on your desktop, and then you are basically deploying in a target environment like Windows or Linux or Mac OS or even or mobile app. So typically, the application, the GUI, the UI, and the business logic, and then the data access layer is all bundled in a single application. So you see the picture on the right. And basically, that's the traditional, we call this kind of monolithic applications, right? Because everything is bundled together. It, in some of the traditional way, we compile it and then become an executable to that environment. So in Windows, you have .exe. In Linux, you don't have just Linux a name of the applications, right? In Mac OS, it's just a name. And in mobile app, you have APK, APT, APK, and other form of application packages. But when you're trying to build an application to serve many users, it's best to design an application that actually is in the cloud. So basically, allow you to have a lot of users coming into your application, so global search, and also allow you to scale and provide high availability, and especially and also security. When you're deploying a single user application on a laptop or a desktop, so you don't have to worry about that much of security because you're logging into your own system. But when you're exposing your data in the cloud, you have to worry about a lot of security. So this drawing is showing the lab that I mentioned earlier, the bookshelf web app is very, very simple app. So when you go to the lab, then initially, and the application basically has a Python script and has actually in memory database to create basically a list book and then display onto the UI HTML pages, and it's very simple. But when you go into the lab, the next couple of sessions, they actually go to and utilize some of the Google Cloud services to create these applications. So basically, there's a lot of Google services described here. And the application, when you compile it, and they compile it into a Docker container. I'll mention a little bit about later and about what the Docker container is. But basically, we create a container and deploy the Cloud Runs. But Cloud Run, the application accesses multiple services. So it access the Cloud API. So basically, this is also using the API to authenticate, authenticating the service itself, the Cloud Run service, to access some of the services over here, the cloud storage. So the cloud storage here, basically, they're using the cloud storage to store static images and static pages in there. And eventually, they create a data store, file store database, basically the document database and NoSQL database, and then they output some of the log into the cloud logging. So for securing the credentials, so when you're accessing from a service account from the Cloud Run to some of those services, you need a credentials. We're going to be touching on that as well. And then we want to store that secrets into the secret manager also in here. And then after the testing, you're performing testing, you certify your application, and you're building a CI/CD pipeline, so like an infrastructure to building the application automatically. So when you are committing your code, this path, there's actually more than this. This path is basically allow you to automatically build the application and run tests. And then after the test is finished running successfully, you push it into Artifactory. The Artifactory is stored in a container, and then that is how when you're deploying the Cloud Run application into and it fetches it from the Artifactory from there. So these are some of the topic when you're building a application for the cloud. You have to worry about what other resources you have to access in the clouds, what resources you use built to deploy your application. So first thing is the compute, right? It's compute. We're going to be touching about what are the compute resources that we need for our application. So this is really basically depending on your application requirement. And also the storage requirement, the database, and then the cloud storage for images for non-structured data. And then networking also is important because in Google Cloud, there's a lot of the virtual private network that you have to create, VPC. And VPC allow you to secure your environment. So they don't really touch on networking that much in this course, but they have touched on the network application in the other certification, like the Google Cloud Engineer certification and Google Cloud Professional Architect. But I want to mention here, when you are designing or architecting your application, you have to consider that networking is very important. Of course, you have authentication. How you identify the user trying to log in is the user that who they are. Authorization, meaning allow you to access certain area of the system. And out of AI, of course, AI, we can build intelligence into the application using Google Gemini or other AI like ChatGPT. The last but not least is the deployment part. It's very important, like I mentioned earlier. So we sort of like touch a little bit about the resource selection, the best practice, what resource that you need to choose for your application based on the requirement. The other best practice we have to know about is the application monitoring and performance monitoring. When you deploy an application to the cloud, a lot of times you want to make sure that you are meeting the SLA, which is service level agreement for your application. The SLA can be defined in your application requirements, right? So if your stakeholders specify that they want to have 99% uptime, so how are you going to guarantee you have 99% uptime? So you have to monitor, and then monitor by looking at the performance, and then maybe using some tool allow you to figure out what your application performance is. And again, so CI/CD is software configurations. What are your dependency and repository and all the setting in your application you have to define. So application architecture, it is a must consider, must think about, because when you're building your applications, you have to think about the architecture for a lot of different things: scalability, high availability, and security, and all of that. So there are I'm going to mention two types of architectures. So I mentioned earlier monolithic application. Like I said, all the GUI, all the business logic, the order, business logic, inventory, payments, shipping, everything is bundled all together in the single applications. And typically, you deploy this application, could be a legacy VM, a legacy system, or a VM in the cloud. If you're in a data center, you probably deploy this to a server in the data. And then the other application architecture is microservices. Microservices is basically a distributed, kind of distributed in multi-services architecture. There's not quite service-oriented architectures, but it's a multi-service. Basically, you break down your application logic. You're grouping your logic into a single environment that they actually run independently from each other. But you need to have some sort of cross-service communication between those. And then the advantage of that is that you can actually develop each services independently from each other. So the GUI basically communicates to some sort of API to the services, and the other services to communicate to each other, they could use some kind of event-driven architecture to support that. And then the code base is modular, and the code base can be developed by different teams. So you don't have a larger team, like on the left side, you have a large team develop the application together in one bundle. So when you are developing the monolithic application, everybody is running the same application, right? In your environment. On the right-hand side, you can actually develop the payment service independently. You can write unit tests independently against the payment service. So now we have touched a lot of this. I think last session, the Google Cloud infrastructure, we touched something about this already. So to access the Google Cloud, they provide a couple of ways to access this. The SDK basically install the client library, install the CLI, which is command line interface. And then the other way to get to the Google Cloud is go to the console. And one other way, I was trying it earlier, that the other way is there's a Google app that you can actually use to connect to the Google Cloud. When I tried it, it seems to be only allow you to access the project that you're currently on. It doesn't let you. I couldn't figure out how to access IAM and all of that stuff. So there's not as full-blown access like you in the cloud console. But so those are the way that you can access Google Cloud using these tools to access Google Cloud. There may be an exam question on this, right? Certainly, there was an exam question for cloud engineer and cloud architect certification on this one. So this is an example, a Python example to access the cloud. So they basically, there's a client library from the top. So you import the Google Cloud storage. And then you define a method, so create bucket, and then you create a cloud client, storage clients. And then in the storage client, you give it a name for the bucket, and then you give it a class. Remember the storage class, there's a nearline, and there's other storage class for cloud storage. And then you can create the bucket, and then return the bucket. So this is basically a simple method to create a bucket using Python. So this is the Google Cloud interface, command line interface. So they basically, some of the command is G Cloud is very often used utility. You just log in it, and then all logged in, and you see the config of the project using G Cloud. And GSUtil basically allow you to access the copy file or to the cloud storage. And BQ is the BigQuery command line utility access BigQuery. This is the example of accessing, getting the list of the compute instance. So the compute instance is the VM that you actually create. So this is listing all the compute instance. So there's right now is listing two of them, the example instance and the instant 2. Okay, there's a question. Can we use Java instead of JavaScript? I don't think it's straight Java. You can use Java. So some of the cloud services, they only allow you to certain languages. I know Python, I know JavaScript, TypeScript, and PHP, and Golang. Golang is actually very cool language. It's like a C language. I use it for my last project. No rush. I don't know. I don't think the rush is supported. So when you go to the Google Cloud Console, there's something called Cloud Shell. When you logged in, it's shared with you at the top of the window. You click on it. Basically, it created 5 gigabyte instant like a command shell. There's like a Linux OS in there. It automatically logged in and everything, so you can access. You don't have to install the Cloud SDK. It's automatically installed for you. So that allows you to interface with all the Google services in the cloud. So some of the lab is actually a lot of the lab that basically you cut and paste the command they gave you to create, like enable the API, create the cloud run, or deploy the cloud run, or do a cloud build. So everything is done from the console. Of course, you can use the GUI to do it, but you have to go find other tool in the GUI to do it. Okay. So this is the Cloud Code and the Secret Manager. Those are the two that I already mentioned the Secret Manager. The Cloud Code is basically the IDE plugged in, and it's actually support VS Code, and then also it support other editor like JetBrains and Cloud Shell editor. It does provide the development workflow that make it easier for you to create and deploy application and debugging applications. You have experience in I think not this session. This session didn't mention that. I think the next session they have some lab that allow you to go to that. So there's another tool, bunch of other tool offline tool that you can use, Google providers use, so you can use the emulator locally. This is useful when you don't want to connect to the cloud all the time, and you can install the emulator locally. I have used Firestore. I have used PubSub locally. It's very successful. I haven't tried Bigtable or Spanner. I believe I use also Data Store as well, because I don't have to worry about logging into the cloud and then connect to the data store, because locally you just connected to it. I want to mention this. I don't know, there's one of the lab that got you go to this. There's a Google offer a cloud workstation. Basically, it's a full-blown development environment that you can provision, and you can use it on the web browser. So that means if you have a Chromebook and have a supported environment to open the web browser, you should be able to do all your development with the Chromebook. You don't have to have a heavy-duty, a high-performing machine to do it. And because they're creating a VM instance with all the tool and everything built for you. So I kind of like this, but I don't know what the cost is. I didn't look up the cost. What's the cost of using it? I think they charge you for the time you use it. Okay, so storage options. I think that we are all aware that last time during the infrastructure we actually mentioned there's a lot of different type of storage option available to us as a developer. So it's cloud storage, Firestore, Bigtable, Cloud SQL, AlloDB, Spanner, and BigQuery. I have a list of slides. Follow all of these. But I think I'm going to just skim through it because we already touched some of it. I'm going to spend a little more time on the one that I think may be helpful to you. So cloud storage. So this is managed service, right? You don't, and you just provision what you need and specify the type of the storage class that you want to use. It is very reliable and cost efficient. It can be accessed, HTTP requests, and everything stored as an object, retrieved by object name. There's a max size of 5 terabyte. That's pretty big. So this is basically ideal for storing the video or images, or maybe unstructured data, static web hosting file, static file that if you have a static website, you can store it here. Firestore is a NoSQL database. It's scalable. It's good for mobile app and web clients. And then there's this document oriented. So the document allow you to store like a name value pair data, but there's a limit in the document. I think it's 1 point something megabyte. I forgot exactly, but there's a limit in it. So you have to worry about when you're designing your the NoSQL database, you have to consider that limit. And this hierarchical data, I believe you can create index in it. I haven't tried. I mean, optimize it faster. I think Bigtable. So Bigtable is another database that we can use, and mostly the ideal for time sequence data, because Bigtable support large large storage data up to petabytes of data. So it's good for either operational and analytical applications. It is also store a single key is a NoSQL database, so it store a key value pair also. Okay. Cloud SQL is just a regular SQL server structured data that you want to. If you have an application want to use structured data, so you create a schema, you upload the schema, you create a database, upload your schema, and that will work for you. Support MySQL, Postgres, and SQL Server. I've used Postgres. Postgres is supposed to be better than MySQL. So my last project, I chose to use PostgreSQL. Let me see. So AlloDB. AlloDB is a distributed high-performance relational service. It's a service, but they actually separate the compute and then the storage, not in the same server or same VM. So they have multiple nodes. They scale horizontally. It's actually an automatic scale. It's a high-performance relational service, and it supports PostgreSQL. It is designed for enterprise applications, which require high transaction throughput, large data size, or multiple replica. So that's good for that. It is also designed for real-time analytic use case. And then this, so I mentioned the architecture, the AlloDB architecture, where they actually separate the compute and storage. So this makes scalability much easier for that, but you don't have to manage that, because AlloDB is a managed service. It automatically do the scaling for you. You just have to specify how many nodes that you want, and what's the read pool, whatever that that you want, is all configurable. And the SLA for this is 99.99. The next one is Spanner. So Spanner is a global SQL relational database that is spanned across many different regions. So you can, if you have a application requires strong consistency in horizontal scaling, so this is good for that. It is also designed for mission-critical online transaction processing applications. So it provides automatic synchronous replica for high availability, and is built for multi-region replication and offer one of the highest SLAs. The SLAs is 99.99, so a little bit one more nine than LLDB. And then, of course, all of these is based on the usage and price. Based on the performance, based on the price also. The pricing is important. BigQuery is also a managed service, and is an enterprise data warehouse for analytics. If you want to have it's ideal for like you want to do machine learning analytic workflow. So this would be good for that. So you just create a data warehouse, and then you can do machine learning, for your application. You support petabyte scale. It has a fast response time. So the last one is the memory store. In case of that, you need to have you want to have getting the data quickly. You want to store, have the data stored in memory, and they recommended you use the memory store. So I got about 20 minutes. About 20 minutes or so, so I'm going to go a bit faster. So I'm going to talk about authorization authentications. So authorization, basically you control authorization, you control who had access to what, right? So who is the principal, the identity? What is basically what resource you're trying to access? The role here specify what access that you have on the resource, like the logging viewer. So you can access the logging service to provide data. So the viewer actually let you look at what the log you put out to the log server. So that was all the authorizations, right? And the identity can be your Google account, service account. So I'm going to mention service account a little bit later, or Google Group, or workspace account. Okay, the Google Workspace account, not Azure Workspace, Google Workspace. And then some of the predefined role and custom role, some basic predefined custom role. So basic role is very hypernistic. That means in each role, for example, role as owner, you never assign something like a service account have own service role on your project. That means the service account, anybody get to this role, they can change your project, they can delete your resources. It's very dangerous. You don't want to use some of this. They recommended that you use predefined role. Some of those roles, very fine-grained role that you assign to certain principle, especially in service account. You're gonna need to know basis, right? You want to make sure that the least privilege for the account. And for some of the role that is not certified or does not meet the business requirement, you can create your own custom role for it. So authentication. So I think authorization, like I said, is telling who can access what. But authentication is like we want to identify who they say they are, right? So they want to make sure this person say, "I'm Kevin Kwan." I mean, is Kevin Kwan allow you to the system allow Kevin Kwan to log in or something like that? So you want to verify the principal is who you are, right? So this is type of application. So you can authenticate to the Google service and resources, right? Or authenticate to your own app. You may want to implement authentication in your app to log on to your app. If you have multi-tenant applications, so you have a lot of tenants, right? Each tenant has many different users, so you have to figure out how to let the user access certain pieces of your applications, right? Certain piece of application data. So you want to make sure their login credential is what you're seeing, right? So to access the Google Cloud Service, there's an API that you can actually go to, but you have to create API key, and then also some of the user account you can use your service account, but they're using an OAuth 2.0. I'll mention that a little later. There's a authorization protocol so allow you to access certain resource. I mentioned service account already using OAuth 2.0. And basically, in your project, you have to create these web access to the Google Cloud resource. So here, some of the workflow is checking on, say, okay, are you running on Google Cloud? If yes, are you running on Google Kubernetes engine? If you are, you can use the Google Kubernetes engine workload identity. Workload identities is another way of authenticating the service. If your local environment, you can still access Google service, but you have to use the something called a default application default login. So you can use the login, create an application default. I'll mention that in the next slide. And then if you run, if you're running in a hybrid environment, like for example, if you want GitHub build action, so GitHub is the build action, but you want to access the Google Cloud build from GitHub. So let's say you're sending a trigger over from GitHub to Google and say trigger the build. And then you fetch the GitHub source code into Google Cloud. You have to have a workload identity federation. You have to set up some kind of impersonation between the two entities. So application default. So the application default is basically in the runtime environment is search for, first I think it's search for the application credential. If it doesn't find it, and then it'll use the credential provided using the GCAR CLI. So I mentioned earlier GCAR CLI, I use to log in first. So, and then the third way to get access is, you can attach to a service account. So in service account, you define the role, the access permission, and so that you can access the resource that you want. So the next couple of slides, basically, I mentioned all of these. I'm just go real quick. So application default, I mentioned already, and then attached service account, and I kind of mentioned it because you can for any cloud service that you create, for example, Cloud Run, you have to create a service account, attach the Cloud Run service, give it permission, give it a role to access the service. For example, data store or file store that you want to have access, you give it you give it in the IAM, you give it permission for it, and then you use the service account to do it. The GKE workload identity, so that also this is configured to IAM also. So you have to enable the workload identity for GKE cluster. So the cluster node, so let's say your GKE cluster need to access the Cloud SQLs, right? So you have to set up the permission and everything for GKE services to access Cloud SQL. So basically, it is impersonate service account to access to this Cloud SQL. And I already mentioned this workload identity federation. So this is like cross the cloud or access into Google Cloud. I have done this in one of my projects. This is really configuration-wise and also very confusing, and then it's not easy to do it. And service account, last resort. You don't want to, you can actually generate a service account key, you can download it. I don't think you want to store it in anywhere locally in your environment. So that definitely, they don't recommend this. So authentications and authorization, I mentioned about OAuth 2.0, right? So basically, you log in, so this is user consent, and then consent allow you to access certain data, and OAuth basically come back and return you a access token. So use your application using access token to access that resource. If the user does not consent, you're not going to get the token back. So you're going to get some error back. Okay, this identity aware proxy is a service provided by Google Cloud. Is a global Google Cloud service, allow you to centrally control access to a certain resource in your environment. It's verify the user identity and then determine what the user can see. So, and you can go to the service, you can configure how you want the user to see your data. So next slide, I'm going to give you examples, right? So here you have three guys. So anonymous guy, he wants to access your public website, for example. And you configure the IAP to allow this guy in. So in the configuration, there's something called all user. You can go in there, okay, I'm going to allow all user for this guy comes in. So IAP, you go to IAP, and then IAP said, oh, I don't have to, because you allow all user access, I don't have to authenticate user. It doesn't even ask the user to log in. But if you have authorized user, you set up the application so this authorized user only access your internet or call internet something within your network. Then the IAP would automatically launch a login screen for the user. The user have to type in credential and anybody's so they log in. You can configure that to IAP. Same thing for general public user. I think the use case for this is that you don't care to managing your authentication and some level of access to your web server. And this is maybe the best way to do it, and you don't have to worry about. For some applications require user authentication. I've used this Firebase authentication to support Google login, support username and password logged in, and it's pretty straightforward to use. Yeah. So you want to store your credentials securely. So the secret manager is definitely one way to do it. And you store it in your code, basically call the secret manager API and get the credential that you need, and then you can use it in your applications. So AI, so artificial intelligence. So nowadays, everybody is actually integrating AI into their application. There are many different use cases for it, and one you can use AI to do computer vision, or image processing, and and analyzing the image and speech to text or text to speech and translation and natural language processing, video intelligence, all of that. So there's a machine learning model you can use and you can deploy. Um, yes, so use the computer vision analyzing image, detecting label, the landmark detection, detecting logo, facial recognition, detection and recognition, um, content, explicit content detections. And then we have other type of AI, which is generative AI. It's a large language model, and it learns a lot of different type of content, and it can actually create new content from what it learns. So basically, they learn from existing data. And then vibe coding is one of the way that, I don't know, you guys experiencing vibe coding, and it generate unit tests for you. You say, you're on the class. You say, can you generate unit tests for this class? So AI is automatically generating the unit tests for you, and very, very powerful. So this next slide basically is describing that. So you have supporting text, image, audio, and do the training and build up the foundation model. And then from the foundation model, if you don't have custom training data to it, it'll create new content for you. But if you want to create custom new data set, then you can actually retrain and then add some document to the foundation model, and then it'll give you the so it give you the new content from it. So I'm working on an open source project for robotic that we integrate AIs. So we kind of build an AI bot, and we use the foundation model, and then we add a couple of documents that, training how to program the robot on all of that information. We trained it, and then we were able to, create create a prompt. So the user asking, how do I create a model and to turn 90 degrees? He's actually give example from it. It's really cool. So this is some of the use case for generative AI. So I mentioned create, and then you can summarize the video, audio, and whatnot. And then also you can read to the document, discover for the document what's contained in documents, and then you can extract and label contracts and clarify feedback and create tickets. So automation, you can do the automation. So I don't have 10 minutes, so I'm going to go to, I have 2 more sections to go to application deployment and monitoring. So CI/CD is pretty straightforward, right? You have a code repository and cloud build on a factory, and then you basically deploy it either to Google Kubernetes engine and Cloud Run, right? But you have to set all this up in the cloud, and and then there's this software shield, so they allow you to protecting your, so in the built environments, right? So the binary authorization basically identify the image integrity. So when you finish building the image, you don't want to straightly deploy to the environment. You want to make sure it contain no malware and anything in it. So the binary authorization, making sure your image is good before you deploy to the two environment here, the Cloud Run and Kubernetes. This is a must. This is a must that you have to do when you are in production in a corporate environment. With I work on project like this. We have to do this because there is FDA requirement in our industry that security is a major concern. So containers, right? So you're comparing container versus hypervisor. So what's the difference between the two? So hypervisor basically sort of like a VM. So your VM, your app, you can live in, you have the guest OS. And the container is very stripped down of the guest OS into very Linux kernel. And the minimum, they have all the dependency that you need, all the library, and just your app, nothing else. And you kind of get a host OS and create the container. I mentioned the advantage is that your code is in isolation by itself. So you can manage efficiently. So this is why I use container, right? Separation of responsibility. Mentioned earlier, though, you can have a different team working on a different container. And it's very portable. You can put it in local Docker image. You can run it. You can, after you finish testing in local Docker environment, you can just upload to Artifactory, and then you can run it. In application isolation, I mentioned, right? So it's all container is all the virtualized CPU, memory, storage. You don't have to even specify how much memory you use and all of that. So this is cloud build. So I mentioned the CI/CD. So compute options. So there is one more compute option they didn't mention. So you have compute engines, basically VM. You have to provision and how to use it. Kubernetes, there's two types of Kubernetes. I mentioned that a little later. And then there's a Cloud Run. Cloud Run have two types, right? Either a container application or a function application, Cloud Run function you can deploy. This really depends on what your application needs, right? The requirements is. So you have to consider your requirement, and then you can decide which one is suitable for your applications. So in computer engine, you have to specify the machine type, the software, and then the memory and CPU, all of that, the instant, you have to worry about the scalability. You have to manage all that by yourself. And this computer engine is good for when you have a data, you want to migrate some application from the data center. So you're just going to take the existing application and then put it in the cloud. So this is good for that. So you don't have to rewrite your application. It's going to run using the VM. Kubernetes is open source platform for deploying and scaling the operating containers. So they have multiple nodes, and each node has a single pod and multiple pod, and then the control plane to control each pod how to run. It's also including the VPC, the networking environment here. I don't have time to describe all of that either. So I've only got 5 minutes left. I'm not sure I can finish everything. So Roman, what do you think? 5 minutes, just keep going, or 5 minutes for you to do a raffle is good enough?
Yeah, let's wrap it up here because the raffle may take a little bit. And again, I just wanted to say, everybody, thank you so much for dropping your questions. Make sure to join the Slack channel. We're going to continue some of the conversations there. But Kevin, how much more do you have? I know that this module
I
was
have like 10 more pages or maybe more. I don't
okay.
think
So what we're gonna do is we're gonna continue sharing the slides. I think let's drop them one more time. I think yeah, why don't we drop them?
I pinned it in the.
We pinned them there, but I added the raffle instead. So
Oh, okay, okay.
I have the link right here. I'm gonna drop the slides from tonight. I just didn't want to give it right away at the beginning.
Yeah, yeah, okay.
I want to, you've been
So, by the
eloquent.
way, all of this content is come from the course resource at the link. They give you all the module. This come from all the module. And
Exactly. Yeah. And then all the content that you've been showing here comes from the module. Same thing that I was talking about, like the mock test prep application and all of that. That all comes from the modules that you've been watching, seeing, and experimenting. So please continue doing so. So yeah, I just wanted to say again, thank you, Kevin, for your time as always. Yeah, why don't I just also open up the camera? Let me see. Let me know if you guys can see me. I'm gonna open it up right now. Is blocking the camera. There we go. How about now? Can you guys see me? Awesome. Okay, great. So yeah, so I just want to say thank you, Kevin. What we could do again, this is something that we do as a ritual, all of us, everybody. I don't know if we may have time for that. We have like a couple more minutes. Is Linda available? I know she's the designated camera opener. What we do is we open the camera and we take a picture as a group if anybody wants to do it. What I'm gonna do while everybody comes up to the camera, what we're gonna do is we're gonna run a raffle, but only for the people who are here present. So if you're watching on YouTube, thank you so much for watching. This is gonna be recorded and we're gonna post it there on our YouTube channel. For the rest of the folks live, please stay tuned, and then we're gonna raffle some cool items for all of you. All right. Thank you so much.